Good afternoon, guys. I got a couple of emails about the classwork for calculus, and I just want to follow up and give you guys a little bit more assistance. If you watched the video from Dr. Summers, you would see that you actually covered 4 rules for differentiation today. One of the first rules was taking the derivative of y equals e to the x, the exponential function. When you're taking the derivative of that, dy dx is equal to e to the x. The function is the same. However, let me just add a little bit of clarification here for you, because when you're taking the derivative of e to the x, you have to be careful because your chain rule here, quotient, product rule, all those things still apply. So for example, if I were to give you y equals e to the 2x, your dy dx, yes, you would get the same exact function. This would be e to the 2x, but notice that there's a composition in the exponent that used to just be x, right? That used to just be x, now it's a 2x. So we have to apply our chain rule here because we have 2x in the exponent. So this is like a composition. This is like having 2x being placed inside e to the x. Therefore, since we have to apply our chain rule, we're going to multiply this by the derivative of the exponent. And in that case, this is just 2. So your dy dx is going to equal to 2 e to the 2x. Okay, again, because you're applying your chain rule here. All right, sometimes if you look it up online, you might see y equals e to the u of x, and you might see y prime or dy dx is equal to e to the u of x times u prime. Here in that case, they're showing you the chain rule. So basically what's happening here, if you're having difficulty making that connection between the examples above and the classwork, you just have to make sure that we're applying our chain rules. Remember your other rules, if your y is equal to ln of x, then your dy dx is going to be equal to 1 over x. So again, just writing that there, if your y is equal to ln, I'm going to write it in a composition form, u of x, just denoting the function on the inside, then your y prime, also known as your dy dx, yes, that's going to be 1 over the argument, but don't forget that you're going to have to multiply that by u prime. The u prime, this is really just the derivative of the inside function. It's the derivative of the inside. It's the derivative of the function that was substituted in, okay? You're going to follow the same exact idea with chain rules, product rules, and quotient rules. Just remember that your other 2 rules here were if y equals a to the x, a being a constant, x being your exponent, your y prime is going to equal a to the x times ln of a. And if you have y equals log base a of x, this is your 4th rule, then your y prime is going to equal 1 over x, and then just times ln of a, ln of the base. So I can walk you through example number 1 here just to kind of help you out. Remember that this is going to be your inside, right? This is going to be that's like having your u of x here. That u of x, okay, would be what's on the inside. So I'm just going to copy this rule over for you here. Duplicate, let's move that over just so you can see the idea. What's happening here, notice in the derivative for the first part, okay, we're going to have 1 over the inside function, okay, 1 over the inside. So our inside here is x squared plus 5x plus 6. So that's 1 over x squared plus 5x plus 6. But now once we finish that, again, I should have labeled that with dy dx equals, note that we have to multiply that by the derivative of the inside. That's our chain rule. That's our chain rule here. Your derivative of your inside here is 2x plus 5. Okay, 2x plus 5. Remember this derivative using our power rule, 2x plus 5. If you want to just clean this up, your dy dx is going to equal to 2x plus 5 over x squared plus 5x plus 6, and that would be your final answer. Okay, that would be your final answer on example number 1. Okay, for example number 2, it's going to be very similar here. except for the fact that when you have your exponent is 2x squared minus 7x minus 2. So again, if you're using this kind of visualization, of the rule that you're using, g prime of x, right? Notice here we kept the original e to the power. So this is going to be e to the 2x squared minus 7x minus 2. And then we're going to multiply it by the derivative of the exponent, that derivative of that exponent. So it's going to be 4x minus 7. Okay, you can put the polynomial in front or you can leave it at the end, but it really doesn't matter. Both are technically equivalent. I like it when the e to the x is left in front, especially if we're looking for maxes and mins. That'll be helpful for us later. And that would just be your final answer. Okay, I hope that helps you kind of get through the classwork a little bit better. We'll be practicing more of these, just writing the equation of the tangent lines, finding maxes and mins and things like that later on Wednesday and on Friday as well.